Bonjour et bienvenue à tous et à toutes. Nous sommes heureux de vous accueillir à la série d'ateliers boîte à outils en sciences humaines numériques. Je suis Jada Watson, coordonnatrice des sciences humaines numériques à l'Université d'Ottawa. Au cours de cette session, nous explorerons comment apprendre, analyser et construire des relations dans et à travers nos recherches. Good morning and welcome to the DH Toolbox workshop series. I'm Jada Watson, Coordinator of Digital Humanities at the University of Ottawa, and I'm excited to bring to you a series centered on learning, analyzing, and building relationships. Before we begin today, I'd like to start a session with an Indigenous land affirmation. Nous rendons hommage au peuple algonquin, gardien traditionnel de cette terre. Nous reconnaissons le lien sacré de longue date, l'unisson à ce territoire qui demeure non cédé. Nous rendons également hommage à tous les peuples autochtones qui habitent Ottawa, qu'ils soient de la région ou d'ailleurs au Canada. Nous reconnaissons les gardiens des savoirs traditionnels jeunes et âgés. Nous honorons aussi le courageux dirigeants d'hier, d'aujourd'hui et de demain. We pay respect to the Algonquin people, who are the traditional guardians of this land. We acknowledge their long-standing relationship with this territory, which remains unceded. We pay respect to all Indigenous people in this region from all nations across Canada who call Ottawa home. We acknowledge the traditional knowledge keepers, both young and old. We honor their courageous leaders, past, present, and future. Thank you for joining us today. Interest in measuring data citation and developing metrics for data is increasing. Despite this interest, research investigating data sharing, data reuse, and data citation practices remains relatively nascent. In this presentation, Dr. Ninkov will introduce work being done in the Meaningful Data Counts project. The presentation will focus on how the DataCite GraphQL API can be leveraged to access, analyze, and visualize research data, metadata using Jupyter Notebook. Dr. Ninkov will walk through the various resources and explain the functionality. Additionally, we'll look at the broader Meaningful Data Count project and discuss subject classification mapping done to improve subject classification metadata, as well as provide an overview of ongoing survey about data sharing behaviors of academics. Dr. Anton Ninkov is a postdoctoral fellow at the School of Information Studies here at the University of Ottawa and the Scholarly Communications Lab, working on the Alfred P. Sloan Foundation-funded Meaningful Data Counts project. Anton holds a Bachelor of Arts in Communication and Sociology from the University of Ottawa and a Master of Science in Print Media from Rochester Institute of Technology and a PhD in Library and Information Science from Western University. Anton lives in Ottawa with his wife Marie-France and their 6-month-old son Adrian. Thank you, Anton, for joining us to share your work today. Before I turn the screen over, though, I just want to note that I'm going to be adding some links into the chat. They're really there for you to explore if you're comfortable exploring them while Anton presents, but there's no, the presentation today doesn't require them. They're also there if you want to explore them later on. So I'll get those in the chat momentarily. I will also be monitoring the Q&A today, so if you have questions, please do not hesitate to drop them in there. If they're technical questions, I will ask them right away, but if they're more conceptual, I will hold off until there's a more natural break in the presentation. Without further ado, I will now pass the screen over to Dr. Ninkov.
Hello, so you can hear me and see me? Okay. Well, yes, thank you, Jada, for that introduction, and thank you all to the participants for being here today. And I'm looking forward to sharing some information about our project on research data reuse and metadata analysis using DataCite and Jupyter Notebooks, as well as discussing some of the broader components of our project. So just a brief outline for what I'll be discussing today. First, I'm going to be introducing our Meaningful Data Counts project, where you'll get an idea of who we are, some of the core research problem of our project, and explaining the methodology we're using, and then actually providing some background on what has already been done. Then I'm going to shift into the main part of this presentation, where we'll be discussing DataCite as a resource and as a partner organization for our project, And then in the third part, we'll be presenting a demonstration of the DataCite GraphQL API, where I'll be presenting first what an API actually is and explaining why this API is particularly useful. I'll demonstrate the API and then go over a Jupyter Notebook and explain what those are and why they're useful for our project as well. In part 4, we're going to discuss some of the next steps we took after we did this project to help improve metadata with subject classification mapping. And finally, I'll just briefly discuss an ongoing survey of researchers on their data reuse and sharing behaviors. So the team at the Scholarly Communications Lab that's currently working on the Meaningful Data Counts project, at least the components that I'm presenting today, are 4 members, including our 2 principal investigators, Dr. Stephanie Haustein, who's an associate professor here at the University of Ottawa, and Dr. Isabella Peters, who's at Keele University. We have 2 postdocs on this project, myself and Dr. Kathleen Gregory, who's also here at the University of Ottawa. Just to note that Kathleen and I have worked very closely on this project for quite some time, and we both consider ourselves mixed methods researcher, but Kathleen has more of a background in surveys and qualitative research, and I have more background in the quantitative methods and data management and programming. So we've been really lucky to have each other to work on this, this project. So to help explain the fundamental focus of the Meaningful Data Counts project, this figure was created by our 2 principal investigators, as well as a master's student here at ESIS, Erica Morissette. So this can help us get a sense of what's actually happening and why there's a problem that we need to study with data reuse and citation. So this is called the vicious cycle, but so there's really no one entry point. We have to start somewhere. So let's say researchers, don't tend to share and cite their data sets because there's a lack of incentives and rewards in academia to do so. And as a result of that, it makes it hard for people like myself and our team who do bibliometric research to study this problem, because the lack of evidence of data reuse and citation, there's not much to look at, right? So that results in there being this lack of best practices based on those studies, and the use cases for doing this are missing. And that means that we have trouble making meaningful data metrics to study research data, which leads back to the incentives. We can't incentivize it really because we don't have the appropriate metrics to study and analyze what's going on in this field. So in this project, one of our key focus is to try and break this cycle somehow. So if researchers share and cite data sets because they're incentivized and there's rewards in academia for doing it, then we will have better data to make sense of that data reuse and citation, which will help lead to better understanding of what that data means and what use cases can be shared about those data, about that data, and then also importantly creating meaningful metrics for studying how people share and reuse data, which will further incentivize research in this area, a sharing of data and reuse of it. So the approach to this project is a mixed methods approach, where we try to tackle these problems in different areas. So the first place, and where the majority of my presentation today is going to be focused on, is within the bibliometric analysis, where we're looking at the data sharing and citation patterns. Now, we know that we don't have a ton of data and that this isn't really complete, but we feel like if we start by looking at this, we can hopefully develop a starting sense of what's going on in this area. As well, in the quantitative approach to our project, we're doing a survey which is ongoing right now, which is hopefully going to shine some light on the data sharing and citation reuse motivations for researchers. Because this is an ongoing project, we have more work to be done in the future, and based on the results of that survey and what we find out, we're going to be conducting semi-structured interviews with some of the participants to get more sense of their data sharing, citation, and behavior, and that will hopefully lead to the development of a data citation theory, which will in turn help us study and encourage data sharing and reuse. So, while this is still a relatively unexplored area, they're certainly not the first researchers to look into this important issue of data citation, and calls for standardization of data reuse and data citation have been around for quite some time, including some of the important milestones listed here, which include the Bermuda Principles, the development of Crossref, and the development of DataCite. There's work that already examines the state of data citations, and this work tends to highlight that there's this impermanent and untrackable nature to how data is referenced and cited and reused. And this is in part because there's often data references being included only in the body or acknowledgements of articles. So it becomes a bit of a challenge to really pull that data out and find what the landscape of this kind of data reuse is, and it's also challenging to create quantitative data on that when it's not standardized. We also know that there is disciplinary differences in between how data is shared and reused. And that difference means that there's this need for disciplinary benchmarks to really understand what's happening within the field. So something that's happening in humanities is very different than the things that are happening in medical sciences in terms of data sharing and reuse. And we know that is the case. So in order to really study data citation and reuse, we need to have discipline and be able to determine that information as well. But determining discipline in bibliometrics with our bibliometric analysis is fairly tricky. There's three broad ways we can think of how that can be accomplished. The first is maybe the lowest hanging fruit in how we think of this is the intellectually. So when someone uploads a data set or an archival staff uploads a data set, there's a manual description given to what that discipline is, which is useful, but there's also challenges with that. For example, the metadata schemas people are familiar with and used to create this data is not always complete, or is not always the same or complete, and it's difficult to map one to one another, which we'll be discussing later today. There are attempts to automate the approaches to this problem, where we can analyze abstracts, keywords, and titles to pull subject classifications from them. This is an ongoing research area. It's definitely of a great interest to us, and it could be really useful, but there's also challenges here where, as anybody who's worked with machine learning, especially with natural language processing stuff, getting to a really high degree of certainty is really challenging. So even if we could get to, let's say, 80%, which would be good, would that be good enough to do the types of analysis we need, and in the future especially? So these are open questions I don't have the answer to, but that's definitely an approach that's worth exploration. And finally, by proxy means that we use external metadata. So if we have something like a DOI that's connected to the data from another publication, let's say, or another research output that we can help pull the subject in for that data set, that can be a really useful tool as well. So the next part of this presentation I'm going to discuss now is DataCite, who's our partner organization, where our metadata for this project came from. So DataCite has been around since 2009, and they're a nonprofit organization that provides PIDs for research outputs. So these persistent identifiers are given our DOIs, which are the international standard for identifying a document. And these DOIs can be assigned to any material. So they could be a physical book or a digital publication, or any research output can be given a DOI. And what DataCite does that's really useful is that it works in two ways. So the user can both upload their work to DataCite so that they can get a DOI for their work, and they can have their metadata in the system, but as well for people like myself, we can use DataCite because it has so much data to gather information about research outputs and to study that that metadata. So like I said, DataCite members both input out data, and DataCite collects it externally. So that means DataCite goes to repositories and other organizations where this information is collected and brings it all together into one place, with the goal that we can really get a better sense of the landscape of research outputs, not just publications, but softwares and whatnot. And there's specific required fields that are in that a user must upload when they upload a document. So they are listed here, where we can see the first is an identifier, which means that the output has a DOI, or as another identifier, so for like a person, that could be an ORCID, right? There's a creator, so that means who the researcher that is involved with producing that data, that is a required field. A title, which is the name or title by which the resource is known by. The publisher, so who has the rights to that entity. The publication year, which is not when the data was uploaded to DataCite, but the year was made publicly available. So we can use historical data as well and have that data, that year there as well. And then resource type. So it could be maybe a publication, or for our project, we're really interested in data sets and software, many other types of resources. And additionally, there's optional fields in DataCite that are not all listed here, but just some examples. And these optional fields can also contain really important and useful information. Like the first optional field is of extreme interest to our project, which is subjects. So subjects can be the subject, keyword, classification codes. Within subject, there's the field of science, which uses the OECD classification system, which is what we which is a standardized way of looking at subjects, which is what we have used. There's also contributors that are that can be listed, as well as language, funding, related items, which is another interesting point, because that means that if a data set is related to a paper, let's say, that metadata link can be established and contained, and then again, a researcher like myself, depending on my research question, can use that metadata effectively. And as well, different versions can be recorded depending on the needs for that. Now, just to really highlight why DataCite is a great resource for our project here, we have this growth of data sets on DataCite. So this histogram here, so it's in French on the side here, but this is a logarithmic scale. So we see it's up to 10 million at the top. And over each decade, we can see that there's been this exponential growth in how many data sets are shared, which may make sense because, you know, in the last 20 years, we've been using computers to create data sets quite a lot more than maybe in the 1940s. But it is still really interesting, and it gives us quite a lot of motivation to study this because of how much growth there is. And I'm sure people are looking at this little bit of an outlier here, which is kind of interesting. It's an outlier because there's one organization that in Ireland that uploaded quite a lot of materials from that time period. So especially because I'm using the logarithmic scale, it kind of sticks out a bit more, but you can really just see the trend that we're exponential growth, and it'll likely double again in the very near future.
Anton, I have a question that just came in for you.
Yes.
I'm assuming you narrowed your DOIs analyzed by the field resource type. You mentioned that field could contain data sets or publication. Is the field a controlled list, or can the creator input any information they want? How do you define data set across disciplines?
So there's a few questions there. There is so there, within subject classification, there are different ways that a subject can be classified. So it can be an open field, but we're in this project, and I'm actually going to be demonstrating this later, but we are using this field of science classification, which uses the OECD classification. So it is a specified list. So if for data to be included in the study that, or in the study in the Jupyter notebook that I'm going to be showing later on, then it had to have that specific subject classification with those constraints. And then the other, well, sorry, what was the other part of the question? It was about DOIs, I think.
Yeah. You narrowed your DOIs analyzed by the field resource type. You mentioned that field.
Yeah. Okay. So
publication.
Right. So yeah, I mean, we narrowed it based on if they had this specific, the OECD classification listed in there, which this might become clearer once I actually show the notebook as well.
Okay, great. Thank you.
So, because I don't know everyone's skill set here, I'm going to be demonstrating an API, and I just want to have everyone really know what an API is. So there's this is a 3-minute video about APIs that I'm just going to run right now, and hopefully at the end of it, if you already know it, you'll appreciate it. If you don't know about APIs, you'll have a better sense of how the internet works these days. So here we go.
Connectivity is an amazing thing. By now, we're all used to the instant connectivity that puts the world at our fingertips. From desktops or devices, we can purchase, post, pin, and pick anything, anywhere. We are connected to the world and each other like never before. But how does it happen? How does data get from here to there? How do different devices and applications connect with each other to allow us to place an order, make a reservation, or book a flight with just a few taps or clicks? The unsung hero of our connected world is the Application Programming Interface, or API. It's the engine under the hood and is behind the scenes that we take for granted, but it's what makes possible all the interactivity we've come to expect and rely upon. But exactly what is an API? It's a question everyone asks. Okay, not really, but we're glad you did. The textbook definition goes something like this. In computer programming, an application programming interface, API, is a set of routines, protocols, and tools for building software. An API expresses a software component in terms of operations, inputs, outputs, and underlying types. Okay, to speak plainly, an API is the messenger that takes requests and tells a system what you want to do, and then returns the response back to you. To give you a familiar example, think of an API as a waiter in a restaurant. Imagine you're sitting at the table with a menu of choices to order from, and the kitchen is the part of the system which will prepare your order. What's missing is the critical link to communicate your order to the kitchen and deliver your food back to your table. That's where the waiter, or API, comes in. The waiter is the messenger that takes your request or order and tells the system, in this case the kitchen, what to do, and then delivers the response back to you, in this case, food. Now that we've whetted your appetite, let's apply this to a real API example. You're probably familiar with the process of searching for airline flights online. Just like at a restaurant, you have a menu of options to choose from. A drop-down menu in this case. You choose a departure city and date, a return city and date, cabin class, and other variables. In order to book your flight, you interact with the airline's website to access the airline's database to see if any seats are available on those dates and what the cost might be based on certain variables. But what if you're not using the airline's website, which has direct access to the information? What if you are using an online travel service that aggregates information from many different airlines? The travel service interacts with the airline's API. The API is the interface that, like your helpful waiter, can be asked by that online travel service to get information from the airline system over the internet to book seats, choose meal preferences, or baggage options. It also then takes the airline's response to your request and delivers it right back to the online travel service, which then shows it to you. So now you can see that it's APIs that make it possible for us all to use travel sites. The same goes for all interactions between applications, data, and devices. They all...
Okay, so, I hope that was helpful for people that maybe have heard of APIs but don't know exactly what they do. They're essentially just ways that we can get this information that we need from these resources efficiently. And the DataCite GraphQL API is actually another layer of an API, which, well, not a layer, but a type of API, which is very powerful, because once we know how to use it, we're able to fetch the data that we require, but limit the amount of processing that's required in the back end. So as you know, as we look to automate these processes, we're saving a lot of time, and it's actually much easier for me as the programmer or anyone using the tool to more literally specify the types of things they want. If you've used an API before, you're probably more familiar with using a REST API, which requires you to typically there's more specific rules that you must follow to get the data you want. So in the situation like DataCite, where we have this giant network with related things, using a GraphQL API is actually much more efficient and much easier to work with. In relation to the video we just watched, we can kind of think of this as making the waiter that is the API more efficient, or depending on how you think of the metaphor, maybe it is the menu is simpler and we're able to request what we actually want in an easier way, in a better way. So if we think about what the GraphQL API is doing for us, we can think of it as this giant network. So let's look, first really micro, we're looking at one data point. So here we have a research output that has a DOI. This output has many things connected to it in this graph, right? The network. There could be a data connected to it, a paper, an institution, maybe there's a lab, various researchers, maybe this is a subject classification, right? So we have this one DOI and it has many connections to important data points that we want to know. Well, when we think of the graph in a bigger sense, those data points are connected to other data points, which are connected to other data points. And we can really start to see in this example that as we start to expand our view of the graph, we get more sense of what's being shared. So in this case, there's this institution that's at the middle, and there's various research outputs like a software maybe, or a data set, or a publication, and they have authors, and those authors maybe are sharing different outputs that are connected to more outputs. And depending on the research questions that we have or we want to know, we can leverage this API and look at this data and make different calculations and assumptions or and evaluations of what's going on within that network of metadata that we do have access to. So like I say, this API and this analysis of the DataCite graph can be useful for answering all types of questions about research outputs and, for our case, research data. So right now I'm going to do a little demo of the GraphQL API. Which is first here. So I have a few tabs that I'm going to run through just to really, and I'll explain as I go through what we're doing here. So the first tab here is the most macro view of the DataCite graph. So we're looking at here, I'll let you run this because it does take a little bit of time to run. So here we're specifying, I want to know about publications. We're asking, give me the total count. So how many publications are in DataCite? And then we're asking, how many connections do publications have with a data set, with software, with a person, with an organization, with a funder? But then we ask the same questions for data sets, how many and what are their connections? And we do that with each of software, people, organizations, and funders. So with this output, we can start to see that how much reach or how many inputs there are in DataCite and what we can do with that depending on how many connections they have, which I'll come back to, I guess, when this, oh, here it is. So yeah, as we can see, there's 17 million publications in DataCite, and there's 6 million data sets that have connections. I'm not going to read all of these numbers, but you can see there's many connections that are within DataCite that exist. In this case as well, there's 11 million data sets currently in DataCite, which is of great interest to us. But now let's, do a kind of 180. So we looked at the biggest, most broadest view of what's in DataCite. So now we're interested in looking at a specific person. We have their ORCID, and we're interested in knowing who is this person? What is their employment history? We want to look at maybe some of their publications. So we want to know the total count. And then for each publication, which we're saying with nodes, we're saying, so this person has publications. Well, what is all of their publications? What's the titles? What's the description? And who are the creators? So if we run this API query, we get that. Would you look at that? It's actually me. I am listed here as an employee. I have my employment with the University of Ottawa, and as well my former employer is listed here, which is company in New York called Database Publishing Consultants, Inc. And my publications are listed here as well. So some from my PhD, some from other research that I've done, and even a project, a paper that we wrote, conference paper that we wrote that is related to the material I'm presenting today is listed here with my partner. So you can see how this could be used to look up a specific person, right? So we can look up relationships between all research items, or we can look up a specific person. We could also look up a specific data set, as this example shows. So here we have a DOI listed for a data set, and we're going to get the title of that data set, when it was listed, a description, some of the usage data. So this is all, useful information to know about a data set. As well as some data sets have different parts or versions included in that data set. And in this example, this has different parts. This example is actually about carbon observations over different locations. So if a researcher was interested in looking at maybe the distribution of interest within this data set, which areas were getting more views or downloads or citations, this data could be pulled and analyzed for that purpose. And I'm sure people are interested in looking at all of this metadata. If you feel like looking through or using the playground to do any types of analysis, feel free. This presentation is not necessarily about the content of these polls, but rather I'm just trying to demonstrate how this API works right now. The next one is another data set look. We're looking at data set, but this time we added an S. So we're looking at all data sets in DataCite, and we're looking at ones that have a field of science classification that is listed as mathematics. And in this query, we're just interested in how many are there. And as well, we want to know some of the authors with their name and how many they have, how many data sets they've published. So we're maybe, with this query, we're getting the top 10 authors. So we maybe are just interested in looking at some of the researchers who are really contributing a lot of data sets in mathematics. And we can see here that there's 36,000, and we can see some of the names of researchers that are, or authors of data sets that are in mathematics. And I'll just, this will be the final one I'll do, but you can also do this type of querying with publications. And if you type the word query and put a word, you can then search the titles and descriptions for that word. So in this case, we're looking at the word climate. So we want to know how many publications are mentioning climate in their titles and descriptions. So we can see that 119,000 publications have that listed. And again, because we're in the playground, we're not pulling all of this data that exists, but we're going to, we could theoretically, and we could also, we're pulling things like the titles, the descriptions, the authors, funding, and various other, and funding references. And if, depending on what we wanted to know, what our research questions were, we could use this data in many different ways to help us explore what's going on in this area based on the data we have in DataCite. So I hope that makes it a bit clearer what we actually use this API for, what it does, and why it's useful. So the next part of this presentation is about the Jupyter Notebooks. So now that we've seen the GraphQL API, we can see how Jupyter Notebook actually leverages that data and makes it an output for somebody to use and build their own research on. So Jupyter Notebooks are tools for developing open source software and open standards and services for interactive computing across many platforms. And it used to be referred to as IPython notebooks, but it now is for many different languages like Julia, Python, and R, among others. And, you know, the fact that it's open and you can share it easily is really great, but really the beauty of using a Jupyter Notebook is that it's open and can be written in a way that it becomes a more readable document than traditional code. So we've always had commenting in code. If anybody's done programming here, you know that you're kind of drilled into try to use commenting as much as possible to make it easier for the next person to come and use it. But with the Jupyter Notebook, we're actually developing a document that has the code in there, but we can provide description and further understanding of, you know, what's going on in context to what's going on. And that hopefully can make the reuse of these documents and these notebooks actually more feasible for other researchers who maybe don't want to or can't go right into the code without any context. So the Jupyter Notebook I'm going to be demonstrating today is one that we developed for a project and was presented at the ISSI conference in 2021. It's a tool to quickly see the metadata of all data sets on DataCite, and it pulls data on command. So that's particularly interesting because, you know, since we've developed this tool, we've been running it semi-regularly. We've been observing what's going on, and we can see the growth in data sets on DataCite through that. I'll also mention, I think one of the links that Jada sent earlier is from DataCite themselves. They've developed, I think there's the link she sent has 10 different user stories of notebooks, and there are many other examples that could be presented, which I can later if there's interest in that, or you can go to that resource and look at it yourself. But today I'm really looking at the one that we developed, which is about examining data sets on DataCite. So I'm going to just quickly jump into my notebook. And here we can see what the Jupyter Notebook looks like, right? So we get to we download from the GitHub this Jupyter Notebook, we run it in our browser. That's another, you don't need any programming software to run this. It should run just directly into your browser. And at the top, we have an introduction to the document. So this reader can see immediately why we've created this, what they should be able to understand when they look through this, what some of that data means and how it was collected, and what visualization at the end is and what it's for. And then I received some help, so I've mentioned those people for their contributions. This first section is the install. So this is useful because, you know, if somebody comes to this and has never used Python or doesn't really program at all, they can run these installs and get the necessary libraries, programming libraries that really are the backbone to how all of this is going to function. We are going to, you know, use Plotly, reuse pandas to help us visualize and control and process the data the way we need to. So these installs are important. The second part is preparing the DataCite GraphQL API queries. So in this section, the first part we're just setting up so it's easier to call the API for the query. So whenever we run a query, we're just running this URL with the extra data that we need to know in it. So it will send us back the information we want to know. So we're just preparing that here. In the next part, we're writing the actual queries out. So for example, like here, we can see that we're asking for the total count of data sets. Here we want to know the total count of data sets, but that have a citation. Here we want to know the data sets that have a subject and a citation. And here we have just the total count of data sets, but for different fields that we're interested in looking at. In this next section, we are just creating functions that are useful to just quickly call that data. So we can say get data and then say what we want to know, and then they will run these queries that we need to do it. So it's just keeping things clean. In the next section, we're managing our data output. So what that means is we're collecting data from DataCite, but now we need to use it in a way that's going to be able to actually both display it and process it properly. So we want to know like percentages, which we were doing here, and we want to make the data into a data frame. So that's what we're doing here. And then finally, we've created just very quick calls to get those data and be done and be able to get the data that we want to know. So that's all kind of the backbones. And again, the goal is that somebody could use that and maybe adjust some of that. Maybe, for example, like if there was changes you wanted to make in these areas, you could write those changes and still build on the backbone of what this Jupyter Notebook is. In the next section, we get to the kind of fun parts, which is actually displaying the results. And we're using Plotly to do most of this work. So for the first example, we're just making figures where we're saying, I want, how many data sets are there? There's 11.16 million data sets on DataCite. Okay, so that's interesting to us. The next part we're interested in is how many of those data sets have a field of science listed, right? So one of those OECD classifications that are standardized ways of classifying the subjects. And we see that 634,000 data sets have that, which is 5.68% of all data sets on DataCite. The next is how many data sets have a citation listed in DataCite. We see that 101,000 have a data set are data sets with a citation, which is 0.91%, which is pretty low. But then we see the number of data sets with a citation and a field of science listed is at 2,071, which is 0.02%. So that is extremely low and is not necessarily great for our ability to study the problem, but it's still interesting nonetheless to examine that this is the state of DataCite's metadata for data sets. We've also output the tables so that both we can just visually see what, or read what is happening with these data sets with these different metadata, but also so that if a user wanted to output this data and use it in Excel or whatever other manner they wanted to examine it, they could use this. So here we have the fields of science listed with the numbers and percentages. We have the published dates. So for the last 11 years, how many data sets have been published and what percentage that makes up. We have the licenses. So what license is attributed to those data sets. And we have languages listed as well, which is overwhelmingly English is the most prominent one. And in the final section, we created a tree map of the subject classification. So we know 5.6% isn't a huge number or necessarily very representative of what the actual distribution of data sets on DataCite is, but nonetheless, we wanted to make this both to study what is there right now, but also so that when more data is uploaded, we can just run this Jupyter Notebook again and get immediate feedback on what's going on there. So we've done this, and again, here we've just kind of we're specifying how we're doing this, what we're doing, and noting some of the things that need to be considered with this. So the first thing we're doing here is we've input a JSON file, which just has the hierarchy of the OECD classification system. So there's 6 high-level fields: natural sciences, medical and health, agricultural, engineering, technology, humanities, and social sciences. And then there's 40 lower levels. So basically what we've done is we're saying, take this table and use this field of science data that we have and parse each of those fields of science so that they're in the appropriate hierarchy of the subject classifications. Once we've processed that data properly, the next part is actually building the visualization. So we just say, we specify what data is aligned with what area from that data frame. And then there's some very basic coloring and sizing that are made. So this tree map shows a distribution of how those data sets are distributed by subject classification. So we see there's the most is natural sciences, then it's medical and health, social sciences, engineering, technology, agricultural sciences, and humanities is the least. And if we click on this, we can see within biological sciences some of the subfields in the OECD and how many data sets. So biological sciences is an enormous subfield of data sets. And if we go to, say, humanities, we can see, comparatively there's less, but within humanities, language and literature seems to have the most displayed. So, when we did this project, we came to some observations that we wanted to move forward with. So we knew we needed more discipline data, and we were using this OECD, or DataCite is, as well as our project, using this OECD fields of science technology. And we're thinking of ways, how can we get more metadata, right? So enriching discipline metadata for disciplinary repositories and encouraging repositories to make discipline information mandatory are very important for us. We have been working with partners to try and figure out ways to do this, and as well exploring automated approaches based on available data set metadata and external information has been considered. Which brings me to the fourth part of this presentation, which is, so once we had done that, we knew 5.6% just was not enough to really make big claims about anything or understanding the data sharing and reuse between the different disciplines. And so this need for more data sets to have OECD subject classification was apparent. How can we do this? Well, more repositories have subject classifications listed using other systems. So we began to work with our partners and think, how can we map different systems to OECD if this is where we're working and how we proceed forward, right? So we did a project with members at DataCite as well as at Re3 Data, where we worked on classifying mapping the classifications of the DFG, which is the German subject classifications, to the OECD. The German system has many more subfields, so it was a matter of placing those fields in the appropriate OECD classification. And then in this visual that we're seeing is the distribution of where those DFG fields landed in the OECD. So, like we saw, biological sciences has quite a lot of data sets. It might be just a very big field. And we see the DFG has over 40 listed in the biological sciences. And another one, which we'll talk about in a few minutes here, worth looking at, is physical sciences, which has 12, right? So this mapping exercise, the goal was that if we could do this and it was and we were confident in the results of it, we'd be able to improve the mapping, the subject classifications of data sets within DataCite to as much as 50%, which would be really great. This is still in the process of being done, but we've completed the subject classification mapping, which is what I'm speaking about today. So there are many subject classifications that map one-to-one. It was pretty easy to do some of them, but those ones aren't really that interesting to talk about necessarily, because they just are subject classifications that make sense with one another. The really interesting ones are the challenging situations, which present problems and challenges that we need to think about when we do these types of activities and when we try to potentially automate this process in the future. So the first example is Asian studies, which is the DFG has listed there. When we looked into this, it definitely had a defined boundary within the DFG, but within the OECD, it was kind of straddling both the humanities and sociology. And furthermore, it didn't really nicely fit into any of the subfields within those. Now, the OECD uses this other category, and our solution, because there wasn't anything better, was to put it in the other humanities and other sociology. But, you know, it becomes, it's a tricky thing because you don't want to make so much noise in the other categories where it just becomes a lump sum place where there's really no, the goal of these classifications is so that we can get better sense of the subject classifications, and we don't want to overuse those. So things like Asian studies going into other humanities and other sociology was definitely a challenging point for us to decide on as well. In this microbiology, virology, and immunology subject, it both fit into the natural sciences, biological sciences, but of course it also fit into basic medicine. So that's fine because that is what this category represents, but it's also challenging because we use those 6 higher level OECD classifications to define these research areas. And then, you know, challenging situations like this come up where we see there isn't firm boundaries necessarily between subjects, but a bit of overlap. And, you know, as I mentioned, this physical sciences example, this is a particular interest to me, both personally and because I find it very interesting. So we see here that physical sciences, you know, has the study of atoms included in it to the study of astrophysics and astronomy. Now, I'm not challenging whether physical science is a good category or not. I think definitely these things have relations to each other and should be categorized, but it is quite, you know, you have the study of the smallest things in our universe to the study of the biggest thing in our universe in one category. It's a bit of a wide field, we could imagine. And as well as researchers of data reuse and data citation, we know, and my father is an astronomer, so I also know from personal experience that astronomers do interesting things with their data, and they have their own thing. Yeah, they do their own things that are different maybe than others areas of research because of observational data and how they share it and how they use that observational data to build upon other observational data, right? So it would be interesting perhaps to look at what astronomers are doing, but because of the classification system we're using, that data, that granularity in the data gets lost as we move into the physical sciences. So the final component I want to talk about today is our ongoing survey, which I wish I could present results to you, but it's actually ongoing at the moment. So I'm just going to describe what we're doing and, you know, hopefully what we can get out of it. So we're looking at, we're surveying researchers from based on their OECD classification. So there's 6 million authors within the Web of Science that have an email, and we contacted 150,000 of these authors, and we stratified the sample based on the journal that they were publishing and what the classification in the OECD was. So we wanted to get a representative sample of what we know is in Web of Science. And we're asking these participants to complete questionnaires on 3 components. So the first is reusing and citing data. The second is rewarding data management, and the third is about their demographics. With regard to reusing and citing data, we're asking questions like, have you ever reused data with other people for any purposes? So like, yes or no, do you reuse data? How would you classify the type of data that you reuse? Are you quantitative, qualitative, both, or other? And they can specify those. And questions like, how frequently do you reuse secondary data for different purposes, like verifying my own data, calibrating an instrument as a basis for a study? So we are trying to really get a sense of do people reuse data? If they do, what ways are their research? How are they doing the research? What ways are they doing it? How frequently are they doing it in those different ways? Those are the types of questions we're asking. Then the second part is we want to know their thoughts on rewarding data management. So we want to know first, does this researcher share their data? Is this something that they've done in practice? And how important is it to for them to know about when other people reuse their data? So questions like the number of times that their data is reused, the information about who's reused it, a description of how that data was reused, right? So do you want to know how your data is reused? Is that something that's important to you? Those are the types of questions we're asking in that section. And then finally, we're asking them about their demographics. So we're interested in seeing, is there a difference perhaps between newer academic professionals to people that are more senior in the field, or people who are coming up now doing data sharing and reuse differently than newer people? And then we ask them their disciplinary domain to also both get that data about where they self-identify their discipline and how does that compare to the way we sampled them. And finally, we ask again which approach best describes their research methods they use. Are they a qualitative, a quantitative? Do they do both, or do they consider themselves doing another kind of research methods? So again, we're very excited about this survey. We've gotten quite a lot of response so far, and we think we're going to be able to hopefully make some pretty interesting observations about this, and that will hopefully lead to our semi-structured interviews we'll conduct and get a better sense of these behaviors as well. So yeah, in conclusion, I hope I've introduced the Meaningful Data Project to you, and you can now see how DataCite, its metadata, is useful for our project, and how those tools and that Jupyter Notebook is really cool for how we're trying to approach this question. Even though it does have its limitations, it's definitely something that we are very excited about using, and we think, again, because we've created this information in the Jupyter Notebook and we're sharing it in such a way, hopefully that will generate more. We can study this problem as it goes on, and when more data is added to DataCite, we can again study it and make more observations about the actual metadata on data sets that we have. Of course, there are these subject classification problems that mapping effort I demonstrated is trying to rectify, but again, there's challenges to that, and we're also working ongoing right now on thinking about what ways we can try to tackle this problem. And finally, yeah, the survey will hopefully give us a better sense of what researchers' views on data reuse and their behaviors on sharing their data. And that will help guide our bibliometric research in the future as well. So thank you very much for listening to my presentation today, and I'm happy to discuss anything further with you all.
Thank you so much. This is such an interesting project to be part of, and I love hearing more about it. We had a question, not necessarily a question, just a comment on this being, maybe I get the wording right. Where did it go? Yeah, just this being really like a lot of information to take in, and so, sorry. I'm having a hard time with words today, but so informative at the same time. One question that we have often, and I usually ask offline, but there's a lot of interest in watching back the recording. So I'm wondering if you're okay with us sharing this on YouTube after. But you can let me know later, and I can post that on Twitter. One question in the Q&A is, out of curiosity, is this process only applicable to European languages, or can GraphQL API and Jupyter Notebook be used in this combination for non-Latin languages as well?
So, I just want to make sure I answer that question the way. So you can definitely upload non-European data and information to DataCite. So you could study that data in those publications within DataCite. Is the question whether the GraphQL API functions in non-European languages? That I actually don't know, and that's a good question, which I should ask DataCite people. I don't really want to answer because I don't know the answer, but I think there is. My experience is that actually here, I'll go back to it just so I can show you. Oops. Okay, well, I guess because I'm sharing my screen, I don't see it all, but there's actually, when you go to the website on the right side here, there's this docs and schema tabs that are usually showing up. And those tabs give you all the rules around using the API and getting the information you need. I've only ever seen that in English. I don't know if there is a way to change how you query based on the language, but it was an interesting question. I am leaning towards thinking it is just in English, just how these components are written. But if we go back to my Jupyter notebook, there are definitely non-European languages. I believe that Thai was number 9 here. I mean, but if you again, and this is 56% of the data sets were in English too, which clearly shows that there's an extreme, use of that language over any other. But yeah, there's Thai, Malay. So other languages are reflected in the data, but I don't know if the actual API can be used in another language.
Okay, thank you. The other question that came in is, thank you very much for your talk. I have 2 questions. The first one, you mentioned the challenges, for example, the classification of Asian studies. I would like to know on what kind of classification the work is based, or who made the classification. So we'll start with question 1.
So the original classification, well, that's depends on the place that so like I had mentioned at the beginning, there's many ways to classify these data. I believe, most of those examples that were coming from the DFG were from repositories, which I think where the user was uploading based on the DFG what they considered that data set to be. But it depends on the provider of the data that you're getting the information from, how exactly that was calculated or given.
Okay. The second question is it possible to use the tools in a multilingual way, or are there challenges or extra tools which are needed? Thank you very much.
Definitely there's, I think since we're all at the University of Ottawa, or many of us, we know that there are challenges with multilingual things, because there's usually not exact one-to-one translations for every single word or every single subject. So I think that definitely does present challenges. And the OECD classifications are in English. So what we were using was, well, actually, I don't know if the OECD has, they probably, yes, they do have, no, I do know they have translations of these categories, right? So you can look at those translations as well. But in terms of, I think the question, if I understood the sense, was more like, how are we taking another classification and bringing it into the OECD, and are we considering multilingual? And for that definitely is very tricky. I think, again, if you're a multi-language speaker, you can imagine how challenging that would be to do. And we, throughout this research, and this is not to make light of any of these challenges, but we definitely do think as well that we have to do what we can and present what we can with the limitations presented there, but perfect can't be the enemy of doing great, right? So because, or good, we can't just not study this because we know these challenges exist. We present them, and then that's the way, and then we work on the challenges moving forward. But I totally understand the question, I think, and like what that implies for studying subject classification. This is a very, very, quantifying the subject of a research output, which may seem like a literal thing you can do, is actually, when you get to the bare bones of it, becomes quite a messy area, which requires a lot of consideration for many elements, not even just multilingual, but what do words mean to the person that's classifying them? How do we know what a word means or what a subject means, right? So this is a very big area, and especially when we try to do this automatically, it becomes like these are big questions that are unanswered, I'll add.
Yeah, thank you for that. Okay, so next question. Thank you for such a great talk. DataCite is such a great service, and I wonder whether folks in the humanities and beyond know its power. Do you have communication suggestions for CRKN and others to promote it, and the power of DOIs to humanities scholars who may be making data but not depositing it?
I think DataCite is a great resource for people, and I hope this presentation has kind of shown what you can do, at least from the bibliometrics angle. But like I had mentioned when I discussed DataCite, you can use DataCite as a resource to upload your own work. So I think being mindful of sharing your work and being a part of this PID DOI community where we're all able to find each other in this network is really important. And I would suggest to any humanities researchers that are listening that want to explore this further to both go to DataCite. They have so many resources available on their website that are helpful for doing this if you're new to it. And, even further, if you want to ask me any questions, I can try to answer them the best I can, or put you in contact with someone that I know too.
Perfect. Great. Potentially the last question. This could come with a follow-up. It's from Chantal Rip, who says, okay, let me see if I can get this out clearly. There are some repositories like Dataverse that prescribe the resource type data set to all kinds of digital objects, for example, PowerPoint presentations, video recordings, documents. Would that have any impact, what is being returned in the data sets, on creating disciplinary benchmarks? And then it's followed up with, I'm going to read it because it's cute. Not sure it's clear, worth asking.
I did. So I kind of am not following. So the question is more about how do we get that data in the DataCite?
Well, I think it's more that some repositories are very loose and liberal with what they mean by data set. Because it says here, Dataverse uses type data set for all kinds of digital objects. And so does that have any impact on what's being returned in your search? I hope I'm interpreting that.
Well, we don't get, so we can get information about the data sets, and that could potentially be something that, if we observed that being so much noise, let's say, into what we're trying to study, that those things shouldn't be included, but they are, and that is in the description, we could definitely try to deal with that. But the current process we've been doing is, DataCite is collecting what the repositories and what users are inputting as that information. So they don't, with 11 million data sets, they don't have people that check every single one or something like that. So I think the concern there is valid, and it's more of I guess, from our standpoint, we're really interested in the disciplines as well too. When we're getting so low that the types of data sets becomes, I mean, that's down the road, maybe kind of questioned more. But I think it is something that is interesting. Yeah, like what do people consider to be data sets? For sure is a good question.
Awesome, thanks. Chantal, let me know. Oh, I interpreted it right. She was concerned by the noise, especially when different disciplines, as noted, have different practices on what is shared. Perfect.
Yeah, and I'll actually just add, we could, if we had better discipline data, that would be something that we would definitely be looking at too. Exactly. Like do the humanities share data in a different way and consider what they share as data differently than what medical people do? I mean, my hypothesis is probably, but I can't tell you that's the case because we're still at, like I showed in the presentation, we're still at this point where we're wondering and we're doing this research very preliminarily. So we're very excited by it, but it is a bit, we want to encourage our communities to do more of this work because we have a long way to go.
Yeah, actually, just even having this conversation makes me think of, one of my disciplinary hats is musicology, and my colleagues don't work with data in the way you're describing it here or the way that I use it, but they refer to a lot of the materials they work with as data. So, yeah, there's definitely a difference of understanding of what data means to them, I guess. We'll make this the last question. Is DataCite open access or is there cost for access?
DataCite is open. You can go and get the data you want from them for free, and you can upload your own data for free.
Awesome. Great. Thank you so much. If you have any lingering questions for Anton, email address is on the screen, or you can send him a note on Twitter. And before we go, I just want to remind everyone that we're back in 2 weeks. So on Wednesday, March 2nd, same time, 11:30 Eastern, we have Laura Horak from Carleton University joining us with members of the Transgender Media Lab, who are going to share their work building the Transgender Media Portal. And with that, I see there's a couple little flags. Let's see if I'm missing anything. All right. If you have questions for me about anything, send me an email at dhnarts@uottawa.ca. And thank you so much, Anton. This was really informative, and I just love learning about what you are doing with our colleagues in information studies.
Yeah, thank you for having me.
Have a great week, everybody. I'll see you in 2 weeks.
Bye.